Hello friends, here in this video we will see a problem on hexagonal prism. Here is the question. A hexagonal prism, side of base 25 mm long and axis 65 mm long, is resting on an edge of base on HP with axis inclined at 60 degree to HP and parallel to VP. A cutting plane inclined at 45 degree to VP and normal to HP cuts the prism passing through a point on the axis at a distance of 20 mm from the top end of the axis. Draw sectional front view and true shape of the section of the prism. So this is the question in front of us. First, by reading it we understood that the type of solid is a hexagon. At the same time there are various conditions given in the question that I'll explain step by step. First, I'll draw the diagram of a hexagonal prism. So here we have a hexagonal prism. In that there is a hexagonal base and hexagonal top. Then since it has 6 corners and these 6 corners are connected with 6 edges onto the top 6 corners and they are forming 6 rectangular faces. So here we have those rectangular faces, and then these are the edges of the hexagonal prism. Now here in the question it is mentioned that a hexagonal prism side of base 25 mm long and axis 65 mm long is resting on an edge of base on HP. So it means here I have drawn the diagram. We can say that this hexagonal prism is kept on HP, that is the horizontal plane. So when it is kept on HP, and when we are looking from the front, we will be seeing the rectangular faces. But when we are looking from the top, we are going to see the hexagonal shape, that is the hexagonal top, or we can say it is coinciding with the hexagonal base. So for the initial condition, we need to draw the hexagon in HP, and the condition is it is resting on an edge, so that edge will be taken on right hand side because the solid will be tilted towards the right end. So let us get started with the solution. So here I'll start the solution part. Now, so here I'll draw the hexagon in HP because it is given that it is resting in HP. So we are going to see the hexagonal base from top. And now for that purpose, in the question it is mentioned that hexagonal prism is having a side of base 25 mm and axis 65 mm long, is resting on an edge of base. So for that, since it is 25 mm long, for that the side is 25 mm and I am going to measure 25 mm from this center. Then in the compass, measuring this distance from the center, drawing a light circle. Since it is resting on an edge, so I want an edge on the right hand side. For that, keeping the point here, next joining these points. With the help of light lines. Then I'll give the notations to it. The height of this hexagonal prism is 65 mm, and here I can say this will be the axis of the hexagonal prism, looking like a point in the top view. In the front view it will be a line, but here it is coinciding with 3 and 6. So I'll measure 65 mm. This is the height of the hexagonal prism, giving it the notations. Here we have points 1 dash, 2 dash. So this is a hexagonal prism resting on an edge, that is edge 4, 5. Now I'll read the next condition. Because I won't be making this dark right now, I'll make it dark only when we have plotted the cutting plane. That is, after getting the cutting plane, we can make it dark. Before that, there is no need to make it dark, leave it as it is. Next, the condition is a hexagonal prism side of base 25 mm long and axis 65 mm long is resting on an edge of base on HP with axis inclined at 60 degree to HP. Now inclination with HP, that is theta, is given. So this is the inclination of the axis. With HP means it will be visible in VP. Now axis and base, they are perpendicular to each other. If I show the axis on this location, so axis and base, as they are perpendicular to each other, In that case, if the axis is inclined at 60 degree, then the base will be inclined at 30 degree. So in the next condition, I'll make this base inclined at 30 degree, so that axis becomes inclined at 60 degree, and then I'm going to plot it. So let us get started here. Selecting a point, then measuring an angle. (30°). Drawing a light line through it. Measuring the base, that is from 4 5 up to 1 2 1 2 and this point is 4 5 then here this edge 1 2 is perpendicular to the base. Drawing a 90-degree line through it, projecting it light, measuring this height as 65. Then marking this point 3 to 6, so measuring the distance from 4 5 up to 3 6 . So drawing a light line through it, and here I have the points 3 6 3 6 . Then this is the front view of that inclined prism, and here if you see this point, this line 3 6 is indicating the axis. So as I have mentioned, axis and base, they are perpendicular. Axis, if it is inclined at 60, then 90 minus 60, base will be inclined at 30. So in short, we have got this inclination as 60 degree of the axis. Now here is the front view of this inclined hexagonal prism, in which the axis is making an angle of 60 degree with HP. It is visible in VP. Then after getting the front view, we are going to plot the top view by looking from this direction. So here is the observer. Now as an observer, those points will be projected first which are closer. So if I see from top, this top hexagonal base is visible, so all these 6 points will be visible. So plotting them first, starting with 1 2 . So 1 and 1 where they intersect, that will give us the point 1. Next 2 is also onto the same line. So here we have point 2, then 3 6 . So 3 and 3 where they intersect, that will give us point 3. Then point 6 is also on the same location. Then 4 and 5. So 4 and 4 dash where they intersect, that will give us 0.4. 5 and 5 dash, that will give us 0.5. Similarly, projecting the points for the base of the hexagon. So here 1 dash and 1, next 2 dash and 2, three dash and 3, 6 dash and 6, then 4 dash 5 dash, 0.4 and 4 dash, 5 and 5 dash. Now after getting these points, we have to connect the points in such an order that outline will be visible, because outline of the drawing is never hidden. So here I can connect the outlines. At the same time, when I am looking as an observer at the top, this complete hexagonal face is visible. So connecting 1 to 2, 2 to 3, then 3 to 4, and in order. Next 6 to 6 is connected, then 6 to 1, 1 to 2, then 2 to 3, and 3 to 3 is connected. Then if we see points 4 and 5, that is 4 dash 5 dash of the base, that is going behind the observer. So observer cannot see the point 4 dash 5 dash. In other words, it is an edge which is hidden. So that will be dotted. Then these edges 4 dash 4 and 5, when 0.5 is connected to 6, that will also be a hidden line because it is crossing the dark line 1 to 6. Similarly 4 and 3 will be connected with the help of dotted line. Now 2 and 2 will be joined because it is a complete edge. Similarly 1 and 1 will be joined. Then 5 and 5, that will also be hidden, so it will be dotted. Similarly 4 and 4 will be dotted. Now after reaching up till here, I'll plot the axis as well. I'll say it is axis O. So in the front view, axis will be O dash, O dash, and here also it is O dash, O dash. So plotting the axis in the top view. So here O dash and O dash is the length of the axis. Now after drawing it light, next I will be locating the cutting plane, and for that the condition is a cutting plane inclined at 45 degree to VP. Now cutting plane's inclination is given with VP, so inclination with VP is phi, and 45 degree with VP, this inclination will be visible in the other plane, that is HP, and normal to HP. Cuts the prism passing through a point on the axis at a distance of 20 mm from the top end of the axis. It means the location of the cutting plane is given, and that location will be measured on the true length of the axis. In the problem it is mentioned that the cutting plane is passing at a distance of 20 mm from the top. So that 20 mm from the top will be taken in the true length of the axis and not in the apparent length. Apparent length is O dash, O dash. So it means we have to measure the distance on the true length of the axis. So from the top I'll measure the distance as 20 mm. Measuring 20 mm. And then keeping it here, I am going to cut this center. So here I get the distance as 20 mm. Next, after getting this 20 mm, I'll give the dimension to it. Now this is the point through which the cutting plane is passing in the top view. So taking this 20 mm and plotting it into the top view. So here is the point through which the cutting plane will pass, and the inclination is given as 45 with VP, so seen in HP. Measuring 45 degree and then drawing a light line through it. So this light line, this yellow line indicates the cutting plane, and we have to cut this hexagonal prism, retain some part and remove some part. So which is to be retained and removed? Let us analyze that. For that purpose, the observer is here in the top view, and when we are looking from this direction, we need to remove the portion which is in front of us. So this portion has to be removed, and whatever is there behind the cutting plane, that has to be retained. So I'll make this portion dark. Making this cutting plane also dark. Cutting plane AA dash. Now as we see here, the portion which is in front of the observer, that is removed, and whatever is behind, that is retained. Next, I need to project these points up so that we get the sectional front view, and before doing that, now when we have located the cutting plane, I can make this initial condition dark. So next, after making this initial condition dark, here the corners will not be connected to the apex because it is not a pyramid. Here we have a prism, so we'll have to leave it as it is. Next, I'll give the notations to the points which are passing through the cutting plane. That is, first, as an observer here, 2 to 3 is the edge which is closer to the observer, and cutting plane is cutting this edge. So I'll give the notation to the point here as A, then projecting this point A upwards, and it will lie on edge 2, 3. So here we have 2 dash, 3 dash, and it is cutting the base hexagon. We have to be careful. Here we have 2 hexagon. One is at the base. The same notations are there at the top. So we have to see that the cutting plane is cutting which of the hexagon base. So here it is cutting the bottom base, which is 2 dash, 3 dash at the bottom. So projecting it light. And here at this intersection, I'll be getting the point A dash. Then where this cutting plane is cutting the edge 2 2, for that point I'll say it is point B. This is the point B in the top view, and it is cutting 2 2 edge. So edge 2 dash is here, that will be projected up. So projecting point 2 up, and now this will give me the point B dash in the front view. Next, after this, the cutting plane is cutting the edge 1 2 of the top hexagon. So here we have 1 dash 2 dash of the top hexagon. It is looking like a line, and here it is looking like a point. So this is the point, I'll say it is point C. So this point C, when it is projected up, will come at this same corner, because C 1 and 2 are onto the same line. So here that will be C dash. Next, where it is cutting the edge 4 5, I'll call that point as D, and this is also onto the same line where we are getting 4 and 5. Now after getting point D, which is on this line 4 to 5, so here, and 4 to 5 it is for the bottom hexagon, so point D will be at this location, and that will give me D dash. Then point E is on this edge 5 5, where the cutting plane is cutting this edge. I'll say that point is E, and then where it is cutting 5 to 6, that point is F. So now I'll plot it with the help of light line, that is point E on an edge 5 5. So here we have 5 dash 5 dash, it will be projected vertically upwards over that edge, which is 5 dash 5 dash. The point here is E dash. At last we have point F, which is on 5 to 6, that is the upper hexagon, we can say. So on this upper edge 5 dash 6 dash, there will be point F. So projecting F upwards, so I have projected this point F, and where it is cutting this edge 5 dash 6 dash at the top, because it is cutting the top hexagon, that will give me the point F dash. So now here we have 6 points, A, B, C, then there is F, E and D. They will be connected in order, and that will be the shape of the cut section. So joining them first with the help of light line. Point A dash and B dash will be connected. Next, B dash to C dash is a line. Then C dash to F is connected. F will reach up till point E, F dash to E dash. Then E to D is connected, and A dash to D dash. Next, after that I'll make it dark so that we can understand which part is visible, and for that purpose, joining A dash with D dash. D dash with E dash. E dash and F dash. F dash to C dash. Then B dash to C dash will be connected. Next, B dash to A dash will be connected. Then connecting A dash with B dash. Now this is the cut section, and if we are looking on this side, A to 2 is visible, so A dash and 2 dash will be connected, that is dark. that part is retained. After that, 1 dash 2 dash, or we can say 1 dash to 1 dash, this is also visible and it will be joined. Then this portion which is f dash 4 dash f dash, so f 5 4, these points are cut and removed, and even up to point E, that is cut. So this much portion will be light, remaining this much portion is dark. Next, I'll draw the sections over here. Section lines are inclined at 45 degree, so taking 45 degree angle, drawing these section lines. So this is the sectional front view of this hexagonal prism which is cut. Next, after getting this, I'll plot the true shape of the section. For that, I will have to make this cutting plane parallel to XY line, and the true shape of the section will be in VP. So here I'll draw a light line parallel to XY. Over this line, I am going to measure the length of the cutting plane. It is starting from this point A, ends on point F. So here we have point A, this is point F. Then taking the distance from A up to E. So measuring from A to E, cutting this. Next, A to D. Then A to C. And A to B. Now after getting all these 6 points on the cutting plane, I'll be projecting them one by one. So starting with point A, it will be projected in the front view. So here is point A, and in the front view it is A dash. So where A and A dash they intersect, that will give me the point, I'll say A double dash. Then point B. Projected with the help of light line, and here we have B in the front view. So where point B and B dash intersect, that will give me B double dash. Then point C. So C, and here we have C dash. Now where they intersect, that will give me the point C double dash. Then point D. Here we have point D on XY line, so that will give me D double dash. Then point E, and here we have E dash. Where E and E dash intersect, that will give me E double dash. At last, point F, and here we have point F dash. Where F and F dash they intersect, that will give me F double dash. Then joining them in proper sequence, first with the help of light line, A to D, D to E, E to F, F to C, B to C, and A to B. So this is the true shape. Now I'll make it dark. Then drawing the section lines through it. Now drawing those section lines. Next, I'll make this cutting plane dark. This is the viewing direction, and the name of the cutting plane is AA dash. This is the true shape of the section, and after getting this, I'll give the dimensions. Here the base side was of 25 mm. Axis height was 65, or we can say the height of the hexagonal prism. This height is 65 mm, and then I'll mark the inclination of the cutting plane and even the base edge. Inclination of the axis was given, that was 60 degree with HP. 60 degree with HP. Then cutting plane was inclined at 45 degree to VP. And with this we complete the problem.